I'll start in a minute. See if anybody else wants to show up. Get everything set up. Probably bad time anyway because the Sunday at night probably not a good time to stream. But I don't have. I missed yesterday, so I figured I'd just do an update today. Hey, looks like it might just be me and you if nobody else shows up. All right, let's get started. I mean, they could probably just do the the review of the stream once I get it up to YouTube anyway. So let's get started. Let me just maximize this so that we can see what's going on. So I'm sorry I missed yesterday's stream. I was busy. I had to be at the hospital with my dad. He got admitted because he wasn't feeling well, and I sort of missed streaming yesterday. So I apologize for that. He's all right. Everybody, he's don't have to worry. He's okay. Just needs to stay there for a bit, and I'll check out with him tomorrow. But otherwise, he's stable, so he's fine. So the this is previously what we had as the animation. It sort of got messed up because I started playing around with some of the parts. But the reason I brought this up again is it wasn't a very efficient use of space. Basically, what we had was bring this back over. Maybe, yeah, maybe I could do that. The animation's all messed up because of the way I made some changes to it without really messing with the animation. So anyway, so this is where we left off last time, and what you can see is it's sort of a very inefficient use of space because what we had is we had this NEMA motor taking up about 45 to 50 millimeters of space here with the at the end of the track, and then at the other end what we had this tensioning mechanism picking up the other 50 millimeters. So what ended up happening was we're limited to, even though this is a 50 millimeter extrusion, we're limited to 400 rail, and the travel on the 300 rail was about 368 millimeter. So it wasn't a very efficient use of the rail and the extrusion space. So because we use the same driven axes on all four corners, we were limited to how much we can actually move this rod towards its edge. You can see this is the dead space, so this is about as far as you can go, and that was a lot. That was like 50 all around. So basically, on a 500 millimeter cube, it was only using like 368 millimeter of it. So it wasn't really great design. It worked, but it wasn't great. So I had to go back to had to go back to drawing boards, like to kind of look at what we can do to improve the efficiency of the mounting system and so on. So basically, what we came up with was I mean, just me, right? So what I came up with was this was let me switch to the other one so you can see better. Okay, so this was the old pulley idler, and you can see it's 45 millimeter and had the built-in um, tensioner. So it was pretty big. I mean, it took up 45 millimeter of um, real estate on our extrusion, and I left about 5 to 10 millimeter space for the tensioner to work. So wasn't a lot of efficiency there. So 50 millimeter doesn't sound like a lot, but on a 500 millimeter extrusion, 50 millimeter is 10%. So basically, we devoted 10% of our space to this idler, so it wasn't very good. So I went back and I redid it and came up with this, which was bare minimum. I mean, you can see that the get the focus here. There's bare minimum of space there for the belt to go through. Is 22. It's only 22 millimeters. Basically, the minimum I could get away with, and still have enough space in there for the 6 millimeter mounting bolt. So that was about as small as I get this part. So we squeezed like basically 30 odd millimeter. The difference between these two is pretty big. So you can see the difference between the two. So took a lot of kind of playing around with it to get the right size. So on the other end, what we had was we had let's see if I can find the right part here. So we had this for with the end stop switch and everything. So this was 50 millimeters, taking up space again on the other end of the extrusion. So what we ended up doing was, this is the orientation, we've lifted the motor off the rail. So basically the motor is now suspended above another idler, and the way it's going to work is the belt routing is going to be from the idler up to the gear and across to the other side. So it gave us back another 30 millimeter on the other end of the axis as well. And because I can move this up and down the vertical, I could adjust the tension on the belt as a built-in mechanism. I don't need another idler. I don't need a tensioner on the idler because it's on the motor now. I can move this up and down and vary the tension on the belt. So that worked out better. So that this combination is going to work a little bit better than the older design. So with those two changes, basically we gained back. I got it down on paper here. 36 millimeter of usable length on the linear rails and on the extrusion. So basically, we have pushed it to the absolute minimum of what I could get away with on the X and Y. And the I show you guys on I'll go back to the display capture. Let's see. So again, like I said, is basically we gained back this space and this space and pushed it all the way out to the edge of the 500 millimeter extrusion. So what we ended up having is let me bring up the sub-assembly. We went from 368 millimeter of usable travel to now 414. So this is how it's going to work. It's basically the belt is going to come through this belt holder around the idler and up around the motor, and then it's going to travel in a diagonal from the motor all the way to the other idler here and loop around to this point on the belt. So by moving, we have about 100 millimeter of dead space above this motor because we needed the space for the bolting setup, or some sort of even if direct drive setup, we needed the space so that we could enclose the top. So there's about 100 millimeter of space above this, so we could adjust this tension pretty much as tight as we needed to across the span. So this is about diagonally is going to be a little over 520, I think 525 millimeter of span across here, and it might droop a little, but the important thing is that as long as it's tight between the two idlers, it will move on this rail. So the rail went from 400 millimeter rail to now 456 millimeter. So effectively, we have gained 56 millimeter of travel on the rail, and the extra 50 odd millimeter doesn't cost you that much more. It's like $1 more for a rail, so you regain that back. And you can see, like, I really don't have much more space in here to gain back, so it's as small and as tight as I get it in. That's what she said, right? In there without really messing things up. The other thing we did was in here is, let me get the motor out of the way. Pulley motor. Oh no, pulley motor. Yeah. So this is the end stop switch, and it's basically going to be mounted with 2 bolts onto the edge of the idler, and the carriage has this smooth finger thing that pushes against the switch before the carriage hits the idler. So you notice that there's 2, one on this side, one on this side, is on purpose because there's going to be another switch on this side that gets engaged as well. So the reason for that is if we were normally, what happens is when you're home on a normal modern printer, you're home to min Z, sorry, min X and min Y. So basically the minimum, the 0 position is where the home is. But there's no max. Like most of the firmware don't have a max X and max Y. By having a switch on both sides, we're basically able to define min and max travel for this rail. SmoothieWare is actually the one that is needing this because they don't have idea of soft end stops. They need a hard end and sort of hard min and hard max for the travel. So this allows you to mount 2 switches, one for the min and one for the max for the travel for the axes. Again, like I said, the motor is separate from the unit itself, and it allows you to move this up and down to adjust the tension. The other thing is I purposely put these 2 mounting bolts so that you can actually loosen them and adjust the tension without taking off the gear. So and these are countersunk so that they don't catch on the motor mounting bolt either. So so a lot of thought's been gone into that. Missed the fillet here, so I gotta fix that later. The other thing is the orientation of the motor is facing down so that the wires come down and could be bundled together with the end-stop wiring as a harness, and then we could actually get this get the cabling out of the way. There's a access hole, not like on top here, so that you could get to, from this view you can see you could get to the set screw for the extruder, for the not the extruder, the gear, the GD2 belt gear. Otherwise, you're gonna have a hard time trying to get a either going sideways or whatever. But he has a hole in top for access hole in top as well. So that's and increase surface area for the belt. So that basically now we have an extra half a tooth on either side of engagement on the belt, and there's more meat for the washer and the mounting hardware. So I was able to kind of push that right out to the edge, so take up as much space as possible on top of here. What else did I change? That's about the two major changes on this rail. And what that gave us was going back to, this is the old one, so we don't need this one. And basically brings us to this. So hide these two before I'll explain that in a second. So just to give you an idea how tight things are in here is the reason why that little finger to trigger the end stop is shaped like that is we basically have 2 millimeter of clearance between that motor and if we need to move that up and down, we needed the clearance. So I clearanced it so that it wouldn't have any chance of hitting that piece there. So and also it looked prettier. It been exactly where it needed to be to trigger the ends up. Hey Aaron! Yeah, I know that access hole probably gonna make it like one big hole there. It was just last minute thought. I need to really reposition that so that it works a little bit better. Also, this is the this is like kind of like the max precision of where we could travel on the spider, and you can see is squeezing zero clearance on this side and about 20 millimeter on this side because of the motor, and this is slightly smaller. So that's pushing it as far into the corner as we possibly can without doing some drastic changes on the design. So, well, the thing is that the nice thing about this design is that the Z is independent of the XY. So, right now I'm aiming for 400 to 450, just so that it's a nice cube. You could go up to 600 if you need to, but the problem with that, it starts getting exponentially larger, right? Because you got to remember, you're going to need another 150 to 200 millimeter on top of that for the XY gantry and the dead space above. So if you feel like having a printer that's going to be, let's say a 600, you can be at 800 tall, so almost a meter, like 800 millimeter tall is going to be almost like a meter. So unless you kind of want to have a 1 meter, like about 3 feet tall printer on your desk, maybe then you go with 600. But that is to be determined. The other problem with having a tall printer is there's two things. One is weight. By being bigger, your prints are bigger, so then your steppers for the Z has to be larger. So that's one consideration. Second consideration is the how do I put this? The speed of how fast you could print. I mean, in theory you could probably print something 600 tall, but at that point you're going to need a volcano. You're not going to really use a regular E3D because the regular E3D V6 with even the biggest nozzle, you're not going to keep up with the speed you're going to need to print. I'll show you guys that in a second. The other thing is it shows 414 for the limit to travel, but at the end of the day, I just tried it with the different size bed, and it travels 420-ish by 420. So the goal of getting to 420 actually works. So we can actually get 420 on all the axes. Um, so like I said, from here from the bottom of the extrusion to the top of this motor mount is roughly 100. So you need 100 on top of that for some dead space. So you're looking at 200 just for the XY, and then whatever space underneath it is going to be for your Z. So that is to be determined. The Just to give you an idea, that's a 600 millimeter extrusion there. So I think back all four corners. You see that that's about the size. So and let's see. From here, from here to the other end, if I could move it from here, that's a 420 millimeter, like XY travel. So that covers that. Like you guys probably remember what it looked like before. That covers pretty much the entire, as much as the area I could cover on the XY itself. So it's been pretty good. So I'm happy with the new revision. Let's bring it back to home position for a second. Okay, so remember I told you guys last time is that this is the Ultimaker 2 Plus Spider. I was able to find this one. I was able to pull off of Thingiverse. This is an E3D mount. Basically, the E3D V6 goes here, and you can see that we could kind of use the same idea. Is use bushings inside of these holes here to bring in an aftermarket E3D onto the same gantry system. So by being compatible with Ultimaker mounts on the rods, it opens up a whole new world of different spiders you could use, and we don't have to reinvent the wheel. So the only issue I found, and I mentioned this on the chat, was let's see if I can get rid of some of these. Which one is this one? Let's get rid of this one so you guys will see better. Okay, so now that we can see a little better, normally the fan goes here, and I'm afraid of the clearance of the fan on this side hitting this extrusion. So I have to kind of play around with it to see whether or not it's going to hit on this side where the parts cooling fan kind of hangs off of there. I can show you guys let's see that. Show you guys what I mean. Give me a second. Okay, so let's bring down the. There you go. Best thing I want to show. Okay, you see the parts cooling fan for Ultimaker. They hang pretty wide on either side of the spider. So so I have to check to see if those will hit the extrusions. If they do, it's a very simple fix. What that means is that I have to lower the rods. So let's bring this back up here and I'll show you that. So what that means is that here where I bring this piece down with a rod holder, I lower this slightly, maybe down. Like if I lower this rod another 10 millimeters so that this starts around here, then this whole spider is lower and it'll just clear the bottom of this extrusion. So if I find that there's going to be an issue with the clearance on these cooling fans, that's a very simple fix. Extend this part 10 millimeter, drop the rod 10 millimeter, and we're still within a pretty good like overhang here for that part. So 10 millimeter is not going to affect that much, but if that 10 millimeter allows us to clear the fan, then great. No, we could just go with that and then we'll clear it. But that was just to show. That was a quick kind of like addition there to show you what we could do with the same rod configuration. We tried all the different spider designs. So let's kind of go into the next thing we're going to talk about, which is bring this back. So somebody asked about, you know, 400, 500, 600 beds, and it gets to the point where I think people just don't know how big 400 is, or 420 is going to be, or five. Like, what they, you cannot understand how big the size is until you actually get visualization of how big we're talking about. So what I'm going to show you is this is 250 by 210, which is the MK42 size, and you can tell like we are considerably bigger than a MK42. So that, just to give you reference, that's MK42. So if we add in, let's say just another slab here, we could add in oh no. Hang on. Technical difficulties. I should have said yes. Sorry, give me a second. I should have done this a while ago, but I've been rushing it. There's probably a better way to do this. I just don't know how yet. So, there we go. Okay. Okay, there we go. Okay, so that outside one is 300 by 300. So that's the debot size. So right now, that's the debot extra large size. It's 300 by 300. It's on the this outside square is the debot 300 by 300. The inside one here is the MK42. This one is what we're gonna get. Is 420 by 420 on this printer. So that's just the visualization of how big we're gonna get. This doesn't really show well, so let's just click through here. So this is MK42, 300 by 300, 420 by 420. So yeah, it's gonna take some engineering to kind of get the Z platform to work, because there's gonna be a lot of weight there to be lifting. So that's another challenge that we're gonna have to face when we get there. But we might have to scale it down. I mean, I think I went a little ambitious on this, but go big or go home, right? So that, just to give you an idea of what 420 looks like. And if I go to the top, you see that close this so we have more room. That goes, the spider goes edge to edge on the 420. So we don't have any issue like before, where we were having issue with the spider not covering the entire covering the entire area of the print surface. This covers the entire area. So I think the having 420 by 420, I think, is good enough for most people. I mean, I don't see you going to 500 or 500, because the only way you're gonna get 500 is if you're gonna go another 80 to 100 wide on both axes. The problem with going another 100 is you exponentially making the printer bigger. If you this rod and this rod, they are only 10 millimeter, and we're having a 500 span across this here. 500 span on a rod. Let me show you last time. Even though it is kind of like unbendable, this is only 400. Getting 500 another like that much is gonna sag because of the weight. Like you're gonna have problems, right? So going 600 on this because you need it to be because you need another 50, you want to get another 100 millimeter out of it is just insane. Like having a 600 millimeter rod, it just insane, right? Just let me see if I can take me. So that again show it. That is about 600, right? So that's gonna give you sagging issues. I'm telling you right now. So probably not gonna go there with the not gonna go there with the current design. I think the current if you want to go that big, you see most of the large format printers that go what we will call what I would start calling half meter by half meter cubes. They don't use this design because the crossrod design doesn't scale up past that. They use remember I think the first few streams we were talking about having the container crane lift idea where the the movement of the gantry up and down the pathway and then having it lift up and down to do the print so that the actual object you're printing stays stationary. So that's pretty much the only way you're gonna get a large format print to work is the part stay stationary. It won't even go up and down. It has to be staying stationary in that one spot. And you move the gantry and the print head around the part itself, and you start printing that way. I would probably look at that once the cube is done. I will kind of tackle that whole kind of half meter by half meter by half meter like monstrosity, and then have it scale up to 1 meter maybe. But 1 meter is crazy insanely large, right? So I think there's a certain point where you kind of say, stop, don't scale it up anymore. Let's see. Don't you have a budget price for the cube? Want to make it bigger, potentially make the cost higher? Actually, surprisingly, no. That's the reason why we sort of settled on 500 extrusion and 450-ish linear rails. Extrusion wise, to go from 400 to 500 was like $1 or $2 per extrusion. So, on this picture, there's 4 extrusion. That's $10 extra to go 100 millimeter longer. So, 10, $15, I say, in that price range. The linear rails, I would guess they're made to be about like an extra 100 on all 4 is gonna run you another $40-50. So the rails themselves are not expensive. What's expensive is the carriages. So do I have the one here? Yeah. So the rail themselves are just cast rails, right? So they cut any length you want, and really like it ends up being very cheap. What's expensive is the carriages themselves. That I think these are like $30 odd, like $35-40 for the carriages, and like $30 for the rail. So when you start having like this is 35, and then you add like 35 and then $45 for the. Let's say you go from $35 for the rail to 45. You're not really gonna like in the overall scheme of the project. You're not gonna see the extra $40, right? So What's going to add to the cost is going to be the rods, right? Number one is the rods is it's actually pretty expensive once you get up to, well, once you start having to use some exotic material like carbon fiber or like hardened hollow shafts and stuff like that to kind of lose some weight. You end up paying more for the rods into extrusion. So that's probably where I would start worrying. And then the other thing is that belts don't really scale. I mean, right now, if you think about it, um, bare minimum, without taking into consideration the gearing and all the other stuff that we're gonna have, you have at least 1 meter of belt per side. That's 4 meters of belt. So GT2 belt at length sags, right? So you have to tension it enough that it doesn't sag, but not enough to bind. So um, I think when you get to a certain point where the belt travel is going to be so long that it's not practical for you to scale past that. Um, I think at a certain point you're going to be going to like if you look at like Core XY, that's even worse, right? Because Core XY has one belt that goes all the way around, and that's more than 1 meter. So that's why one of the things that I'm kind of stay away from that whole design is that I didn't want the long belts that they run. So let's see what else we can talk. Well, I'm trying to figure out what I was wanting to cover. So the largest PCB heater I've seen, and the ones that I count like that we might and might not be working on, is 300 by 300. And that's this square here. To go to 420, there's no way we're gonna get a 420 by 420 PCB. That's gonna heat up in a reasonable amount of time. So, what that means is that if you're gonna build this thing, you're gonna go to a silicon heater. So there's no question about it. It's gonna be a silicon heater on a MIG plate, like we described before. I think what's gonna happen is the MIG plate's gonna be, if at 420, I'm probably gonna spec out 3/8 or half-inch MIG plate with a 110/220 like AC powered silicon heater so that it gets up in speed. And also I'm probably thinking that you're gonna use one like the G-Max. I think you guys have seen the G-Max one before with the external controller. So see if we can bring one up here. Okay, show that already. Show the open block, do that. Hopefully it brings it up. Yeah, so we showed this last time too, I think. So the this thing where sort of the G-Max type where you have you set the temperature externally from your controller, because these things generally would be more accurate. And then you also, like I mentioned last time, is that these are self-contained. So basically, you plug it in the wall, stick it on the back of the heat bed or the aluminum plate, and you ready to rock, right? 600 watts. This is 220 by 200 by 300. I talked to these guys already. Kinovo, they would make any size you want. So I already asked them about the 400 by 400. We don't go edge to edge because we need space for the screws to mount to hold, and then also a screw hole for the grounding. Because that for the house current, you want that whole plate to be grounded so that if something goes wrong with the heater and it starts to short, it would short to the ground on the screw so that it would be safer. So you need space for the mounting and need space for the grounding screw. So at a 420 by 420 bed, you're probably gonna go to like a 360 or 380 by 380 silicon pad. It'll heat up to the edge. Don't worry about having dead zones. The entire plate will be heated, so that you don't have to worry about it. It's just that you need the least space at the edges so that you would be mounting. You have space to mount. A lot of people make that mistake. They buy a 300 by 300 heater, and they have a 300 by 300 plate. So that when you stick it on, it's like, well, how do you mount this board now? You can't drill through the silicon pad, so you're sort of stuck. So yeah, you need to kind of have that clearance. So I think leaving 20 to 40 would be good enough. I'll show you guys. I'll bring that up. Midwest mix. I think it's mix 6 or something like that. There we go. Mix 6 plate. So basically, it was what they call jig plate. So all the CNC machines that you see with the reference surface that they use, they use cast aluminum. So I wouldn't call it perfect flat. It's flat enough. I think it's within 0.38 millimeter at the worst. So I think, like I said, I mentioned this a few times, is you will buy mix plate, mix 6 plate, and you can use it as is, or you can take it to a machine shop and you have them deck it. Decking it means they'll put it on their reference surface and ground like a mill off the top so that it's perfect flat. Then you can have them perimeter, like smooth out the perimeter, maybe put a bevel on it, drill the holes, and hand it back to you. So basically, you have a perfect surface. That probably runs you, depending on your local CNC guy, he might run you like 60 to $100 for his time to do that. I had to price it out. If I could get a good price on it and I could get a whole bunch of them made, I'll do that. But generally, it's about an hour to 2 hours of his time, depending on how well he does the work and how many you're going to do. If you do one off, then $60, 60 to $100 would be about the price when you pay. Plus like 30, I think it's like 30 something for the plate itself. So you're looking at 100 to $150 for the plate, all prepped and ready to go. So they will, like, if you give them the drawings, they'll draw out the holes and everything for you. So like I said, I'm probably looking at 3/8 or ½ inch. So 3/8 is, I think, let's see, do this here. Millimeter. Yeah. So basically, it's about 9 mil. So a 3/8. I think 3/8 would be good enough, depending on what you want to do. ½ inch is a little bit thicker, and you could kind of take more material off to deck it. So I'll just see how much it costs here. If we go 420, so 16.5 inches. So 16.5, 16.5. Whoa, okay. $125. Like, I gotta talk to these guys about the pricing, because I think that's a little bit odd. Because I bought one that was smaller, and about like the 300 by 300 wasn't 120. It was like 30, $40. So I have to talk to these guys about the pricing. So yeah, I think it gets funny when it gets up to the larger one. But we'll play around with it, see what we could get. But the most of the printers, like the Voron, look at the Voron. It actually it's the same thing. It uses a plate as well. So let's see if I can bring up a good picture of the Voron here. I think that's a good one. So that's 3/8. So it gives you a perfect dead flat surface, and then you work with the probes, so you don't have to worry about like bed leveling. You can actually use the bed leveling and smooth way to kind of level the bed. So like I mentioned, not like in the well, just not just I mentioned just now is that you need to leave space for the mounting holes. So we try to put them as close to the edge as possible so you don't lose any space. And we don't need one in the middle for the belt holder or anything like that, so it's kind of be good. I think like it's proven, right? Everybody's kind of using this method instead of like a PCB. Like a make plate, I think is a good surface to kind of work with. The D-bots and stuff like that, they use this really not very good picture. Let's see if I can find a better view image. So they use no, it's so small. They use a PCB. The problem with the D-bot using a PCB is that the PCB is not very good. So this one. Yeah, so this is what they use, and I bought one of these, and there's noticeable sag. I mean, like when I say sag, I mean it's like literally you're a quarter inch or some spots in the middle where you're like a quarter inch deep. You have to kind of brace it up in the back, and it just ends up being like a total clusterfuck with with those PCB beds. So they don't make them well, so that's part of the problem, and it you have to kind of do all sorts of crazy shit with it to get it to work. So I'm not gonna go there with that. And the other thing is that the wheels. I took a lot of time to align the wheels on those on the V slot. This nightmare to do. So I'm not gonna go there. So that's pretty much the yeah, there you go. Roll on bed plate. So um what was I gonna say? Oh, so let's so that's the update of what's been happening the last few days. Like why I missed, as I mentioned, my dad's in the hospital. He's okay. I'm gonna see him again tomorrow. So hopefully he'll be back tomorrow. I don't have to really worry too much about him. Um, Hope he has a speedy recovery. Um, just to wrap up, I think I mentioned that we saved some space on the XY. We went from 368 to 414, so we broke 400, which is good. I think 400 by 400, and I'm gonna leave the reference design at 420 just so that we could get that inside joke going. It's like a 420 cube. Um, if you don't know what 420 is, go look it up. It's kind of funny. Um, don't do it at work. Do it at home. Look up 420 when you're at home. Um, for my first build, I'm gonna go 420, 420, 420, and then I'll probably end up raising that up to 500. I think 420, 420, 500 or 600 would be a good decent sized printer. But I strongly suggest if you're gonna go with this printer to go to Volcano. I mean you guys understand that with E3D V6, with even a 0.4, 0.6, you're gonna be waiting forever for print on this printer, and I don't suggest it being your only printer either. I think what's gonna happen is when you print large objects, you're gonna use this printer. But if you're gonna be printing like 10 or 15 spinners, it's not the printer you want to use, because the the it's kind of like buying a Ferrari and driving it in the back alley. Like it's not in this. It's not in the. It's not the right tool for the job. I think you end up keeping hopefully you have Haribo 3030 as your everyday printer, and then you have this Haribo Cube that you're gonna use to print large objects like face masks and stuff like that, like or like cosplay materials and stuff like that. And Pat mentioned this last time, and I think he alluded to it, but he didn't really mention it. I think a few people talked about this. Is just for reference, the if I wanted to on a on the current iteration of the Haribo Cube, I could print the entire Haribo 3030 inside that volume. So technically, I don't have to buy the extrusions. I could just print the entire printer. Yeah, that's how big it is. So think about that for a second. Like I'm able to print the Haribo 3030 in the Haribo Cube. I think that's an achievement all by itself. So the I guess linear rails are being ordered already, so they are on their way. I'm looking also at the hollow tubes. They haven't gotten back to me on hollow tubes. Hollow tubes, I'm not sure if it's really needed, but because it's really expensive. When I say expensive, a Masumi rod was $8 to $12. A hollow aluminum rod from my guess was $28. So $20 more for a hollow rod. So I'm not sure if that shit is needed. So I didn't. I actually asked them for a sample. They're gonna send a sample one. So yeah, I was thinking of that. That's gonna be model. You know, like it'd be kind of cool. Is I'm not gonna say that in the beginning. I'll build the prototype and I'll print one, and then that's the picture. Is it printing a Haribo 3030? Right, so that would be kind of cool. It has to be printed in two pieces because like the support for the gantry would be stupid large, right? So um, the bottom the bottom rectangle is going to be printed in one piece. Then the gantry itself will be printed laying flat, and then there's going to be holes on the bottom. You just basically bolt the gantry on top, and you have a printer. Like that's it. So I think then you could print all the other parts, and it'd be like probably one of the most printed printers, like one of the most printable printers if we did that. So it'd be kind of cool. I did get those plates. Remember? So I've been slacking off. I think I got 3 or 4 people signed up for the alpha. If you want one of these limited edition, oh man, it's gonna be hard to see. Haribo Cube Alpha Team plaques. Just sign up for the alpha. So just so you know what's involved, you let me know you want to be in the alpha, meaning that you want to help me test, and you want me to help me build this printer, validate the design, muck around with the firmware, and kind of use it once it's built, so that we can kind of shake down all the issues with it. I budgeting about $1,000 plus or minus 200, let's say. I'm gonna work hard on getting the pricing down for the parts. I always try to get IGES to give us some break on the pricing because they are pretty good. They've been working with me on it. And Sumi / T-Sun, I'm working with Megan and T-Sun to see if they could get us the extrusion cut and drill the same way. So so far it looks like we're gonna be under 1,000. Most of the cost is gonna be um, in the electronics. There's not a lot of frame parts, and there's not a lot of printed parts. I mean, you guys already seen all the printed parts of XY, so there's not a lot of printed parts, right? So, um, if I had to guess, silicon heater, build plate, the controller, the motors, the hot end. I mentioned motors and the two Z steppers with the integrated lead screws. Those are going to be the big ticket items. So if these are 150, 200 piece, you're already looking at $1,000, and the rest of it is kind of like the plus or minus that. So if you're there's going to be some spots where we could kind of get a group buy together, something to buy something, then we'll do that. But I want, like, right now I'm number 0 as always. I always keep 0 for myself. 1 to 9, I think we're up to 4. So 5 to 9 is available. We will alpha test for at least 4 to 5 weeks. So you want to get in early on it. You're welcome to do that. Let me know on chat you want to kind of sign up for the alpha, and then I'll put your name on the list. And then set manager is gonna basically put your name down on the plaque, and we'll work out how we're gonna pay for the shipping. Because I want you to pay for the shipping on the plaque, so I want him to take it out of his pocket. So you get the alpha plaque. Then when the beta comes around, there's gonna be beta plaques. So if you're alpha, you want to go to beta, great. If you don't, then basically you get 1 plaque. If you go to that beta team, I'm hoping that at that time, you will give somebody else a chance to kind of play around with the printer. You'll still be in the beta, but the plaques will be for the beta guys, maybe. I'm not sure. Then when we go full production, like full release, then we will first 20 or 30 will get a plaque as well. So I know a lot of guys didn't get one when they built the Haribo 3030, but that's life, right? You get on board early, you get a reward for it, right? So hopefully there'd be more interest this time. I think that's it. I'll open it up for general questions. Things that we want to talk about, not just the Haribo Cube. We could talk about other things too. Coming up to an hour, I think it's been pretty good. I think we've been hitting 1 hour mark pretty consistently lately. Let's see if I have any cool stuff to show you guys. Not really. I really should get going on that D-bot. It's been sitting there. It's kind of been, like, you guys see it all the time, and it's kind of bugging me that, it hasn't been put together. I haven't really seen any good deals lately, so I think it was this one. I was thinking about this one. This is a pretty good deal if you want like something to show off on a portable basis. This is a pretty good deal. It should work pretty well. The overhang on the gantry is not that big. The design of it is pretty good. It's running on V-slot, and it's self-contained with all the display and everything for $167. This is a really good deal. So I think and wow, maybe get free shipping 11 to 19 days. I should get one of these. 56% off. Let me put these link up here for you guys. Put it in chat. So that is an awesome deal, actually. Like, now I'm thinking about it, I should get one of these. $167 for a 3D printer. Come on, like, you really can't go wrong with this. And you get $3 off because you spend $150. So $164 will get you a pretty decent looking printer. I think this is a good deal. For shit prints that you don't really care about, I think this is a really good way to go. All metal construction, it's got electronics, and just like print for a while with it. If you don't like it, always just upgrade and strip it and stuff like that for the parts. It's still worth it. Like $167, you really can't go wrong with this deal, man. Yeah, I should make this part of the stream is the go shopping with Joe. Duplicated 7, that's a good deal too. Dude, SLA printer, $350 plus $136 shipping to Canada. So what? $470 shipped to my house. A SLA printer. I think think this is a pretty decent printer too. So like for 486 to 14, I guess that's what it is. That's a pretty decent price for that printer. Like for a SLA printer, man, these things are coming down in price like mad. I should really get my Form 1 going soon. Create bot. Oh, the flying bear. Yeah, this is the one where it's an interesting design. I gotta admit, it's a cross between a gantry printer and a Ultimaker. It's kind of like bastardized version of it. Oh yeah, Voxel Factory. So I think they have a large format printer I wanted to show you guys and see if I could go there and see if they have it. They don't look at their pictures, though, that's the problem. So for those who don't know who didn't get the email, Voxel Factory, which is the Prusa reseller in Montreal, they recently started carrying Ultimaker. So if you need Ultimaker in Canada, they're the dealer of choice now. So go there. Oh yeah, this is one. So let's see which one. Go big or go home, right? So let's go this one. Wow, come on, so this is what I was talking about. Basically, the piece that you're printing. This is a really bad picture of it. Let's see if I can find a better picture. Wow, better picture. Okay, good. So, of course, now it's going to be too big. Basically, the print surface stays consistent. It doesn't move at all. So what moves is your print head across this gantry. In this case, I have dual extrusion, and you can see these are the Nemas, and you can see how freaking big this is. How it works is this whole assembly goes up and down, like this whole gantry, right here. This whole gantry goes up and down, and it goes to the basically it lowers itself to the floor, and the gantry starts on the bottom and it works its way up to lifts itself up to the top, and then starts printing the part on the print bed. This is going to be the only way. One of the only ways you can get that big of a print is when like the part that you're printing doesn't move, because you end up moving 6 or 7 kilos worth of which is about what 12 to 15 pounds worth of weight on that. It just doesn't make any sense, right? So let's see. So 1 meter, 1 meter, 500. So technically, if we go 600, we could print taller than they can. So just to like how big of a printer we're going to be building. So 1 meter by 1 meter by half a meter is huge, even by any standard. So, but I think you saw the price there was $39,999 Canadian. So if you're able to get half meter, half meter, half meter, which is what we sort of aiming for, like 420, 420, 420 is like a little bit less than that, I know, but for the $1,000 or $1,200, whatever you're gonna be paying for it, I think you get an awesome deal. It comes in lower price than the loose part and all the other guys, so hopefully you guys will enjoy that. But I saw this printer and I kind of thought, hey, that this is pretty cool. I think this is one of the lower end models where it doesn't come with a bench. Like, it doesn't come with a roller bench, but it works the same way. So, hopefully, see that? That's how it lowers the gantry onto the floor. Is the gantry now is in a low position, and it basically works its way up to the top by lifting this whole platform. So like this, not this gantry, sorry, not the platform, but lifting gantry by lifting these two posts. So that's how it works. And even that one is $20,000, right? So it is what it is. If you want to print furniture, that's what you're gonna get, right? So yeah, this is a furniture printer thing. This is like ridiculously overbuilt. Big rep. Yeah, this is where you kick your family out and you build a printer that takes up the whole room, right? So anyway, I'm not gonna linger. I don't like it when lingering. So was I once again I apologize for missing the stream yesterday. Like I said, I had to be at the hospital, so I had a little free time tonight. I thought I'd catch you guys up on what's been happening with the Haribo Cube, and I will take Aaron's suggestion and kind of mess around with the access hole, but I sort of put the access hole directly in line with the um, center of the motor. So maybe I just gotta make this, instead of hex, make it a little bit bigger so that you have a little bit better access to that hole. Yeah, he's doing fine. I mean, he's recovering. And there was a change in medication, and he wasn't really uh, happy, like health wise. He wasn't really happy about the new medication. So they have him back on the old one, and then they have him an IV, and just want to monitor him for a bit to make sure he's okay. But otherwise, he's fine. I mean, I checked on him a few times already. I spent Friday, Saturday, Sunday with him, and tomorrow I'll spend some more time with him tomorrow, make sure everything's okay. So I'll keep you guys updated. But in between the visits, I'll be able to kind of squeeze in some time to work on these parts. So I think I was happy that we didn't have to work on the spider, because that would have been a lot of work. So right now that means I could jump from the XY right into the Z and work on the Z platform. We have a printer, so I'm kind of happy that we didn't have to reinvent the wheel there. Um, anyway, it's like, again, thanks for asking about my dad. I think he'd be okay. I'll update you guys on that as well on Wednesday. When hopefully I'll have him home by Wednesday, so then I'll have him, maybe when he comes down to the basement, he'll say hi or whatever. Like you guys saw him last time too, so I'll see you guys later. See you guys in chat. Thanks for tuning in. All right. Of course, I'm gonna have to drop something, right? Okay. See ya.